on a tiny planet called Earth, in a tiny speck in the vast universe, life was born. It evolved over billions of years, producing a brain, which gave rise to science and technology, and created tools for viewing the universe, and which today is working hard to understand the nature of the universe that surrounds it. The island of Hawaii has been described as the closest place on Earth to the cosmos. An array of giant telescopes and various other cutting-edge observation instruments continuously gather information and add it to a wealth of digital data stored in computers.
Welcome to the world of the Digital Cosmic Encyclopedia. The computer where I reside is a library of every bit of information on the universe that humankind has ever collected. Let me be your guide, and we'll wander freely through the immense amount of digital information stored here. You'll see something of the vast cosmos, with all its mystery and wonder. From ancient times, humankind has created various instruments to probe the mysteries of the universe. And with each new development in observation techniques, it saw a different universe and gained a new world outlook. This is humankind's first astronomical telescope, used 400 years ago by Galileo Galilei. This small telescope, 4 centimeters in diameter, served to spread the idea that the Earth circled the sun. It opened the door to modern astronomy. This 50-centimeter telescope appeared 200 years ago. With it, humankind realized that the solar system was only a small member of a galaxy. At the beginning of the 20th century, a large telescope, 2.5 meters in diameter, was built. Using it, humankind studied distant galaxies and found that the universe is expanding. And today, astronomy has entered an age of digital instruments. A characteristic example is the Hubble Space Telescope, or the Flying Telescope in Space, launched in 1990. Now let's see just what today's digital observation instruments are capable of.
The Hubble Space Telescope orbits Earth at an altitude of 600 kilometers. It continuously sends back extremely clear pictures, which are unaffected by the Earth's atmosphere. This is a picture of Mars taken by the Space Telescope. Let's compare it with one taken from a telescope based on Earth. The turbulent and clumpy atmosphere of the Earth causes images to become blurred. The Hubble Space Telescope has, for over a year, taken a series of pictures of Mars as it rotated about its axis. Because the images are in digital format, it is possible to use a computer to paste them together and adjust them for color to build a complete picture of the red planet. The Space Telescope gives a clear view of the planet's northern polar ice. These are images of Jupiter taken by the Space Telescope. Processing by computer gives us a moving picture of the planet. We can clearly see distinctive bands in the planet's atmosphere. How does the Hubble Space Telescope produce such amazingly crisp pictures? The Hubble Space Telescope is 13 meters long and 4 meters in diameter. It houses a primary mirror 2.4 meters across and a secondary one 30 centimeters across. The two mirrors work together to focus the faint light from distant sources to a point behind the primary mirror. Behind the primary mirror lies a series of instruments for detecting light at varying wavelengths, some in the visible spectrum, others in the infrared and ultraviolet. The Wide Field Planetary Camera 2 has been of particular importance. Let's compare its performance with that of a ground-based telescope. This is a picture of the Helix Nebula, taken from a telescope on Earth. The nebula is the remnant of a star that has come to the end of its life, silently ejecting into space the material that composed it, such as hydrogen gas. At its center, we see a whitish dying star, the remaining core of the original star. Let's take a look at the same nebula through the Space Telescope's Wide Field Planetary Camera 2. The camera consists of 4 high-performance CCD detectors, large and small. We can see a large number of small objects within the spreading cloud of gas. Each of them is 6 billion kilometers in diameter, large enough to contain our solar system. They are thought to be objects that were too small to condense into stars, and which are being carried along by the powerful stream of expanding gas. We were able to see, for the first time, the fine structure of the nebula, something that telescopes on the Earth's surface could not have revealed. Now, let's turn to some of the digitized images that the Hubble Space Telescope has so far taken. This is the Hourglass Nebula, as seen by the Hubble Space Telescope. Gases flowing out from a dead star describe 2 beautiful rings. The Space Telescope's images consist of digital data, and when fed into a computer and processed, they can be enlarged and viewed from different angles at will. The center of the Hourglass Nebula has a bluish glow with a bright white spot in its middle, the remnant of the original, now defunct star. Astronomers think that our own sun, too, will one day look like this. This is the Egg Nebula, at a distance of 3,000 light-years from Earth. It is a cloud of gas produced by a central star which is nearing death. Gases and dust composing the star are being flung outwards in concentric shells at fantastic speeds. This is the NGC 1850, photographed by the Space Telescope's Wide-Field Planetary Camera 2. It is a large cluster of up to 10,000 stars. With a telescope on Earth, however, it appears as a single point of light. Oddly enough, an analysis of the image has revealed that the cluster consists of two separate groups of stars. One with yellow stars, 50 million years old, and one with white stars, 4 million years old. This is the Eagle Nebula, or M16, 7,000 light-years from Earth. It has a strange shape with its row of 3 eerie-looking dark columns. These are clouds of dust and gas, the material out of which stars form, silhouetted against powerfully bright stars in the background. The columns of gas and dust in the Eagle Nebula are, in fact, nurseries where newborn stars are being formed, one after another. Each of the small projections at the tips of the columns conceal embryonic stars. Although we've said the projections are small, they are still large enough to contain our solar system. Infant stars that have blasted away surrounding gases and only just begun to shine have also been found. How does the Hubble Space Telescope communicate the digital images it takes in space back to Earth?